So our next example is capitalized costs. So if we say capitalized costs, for example, you are to purchase a property, what will be your capital? So these are the things that you need to consider. So we have the first cost. This is the first cost. After R years, you are to replace that property or that equipment. For example, after R years, you are to replace that property, and you will be needing the this amount R to purchase a new one. That is plus R divided by 1 plus I raised to every R years minus 1 plus A over I. That is the annual maintenance. Yung A over I natin, we have this A over I as the perpetuity of the maintenance. If we have an annual maintenance of the property or the equipment. So let's have an example. So this is the main equation of capitalized costs. So at 6%, find the capitalized cost of a bridge. Whose cost is 250 million. That is the first cost. We have a first cost equal to 250 billion, and life is 20 years. If the bridge must be partially rebuilt at a cost of 100 million at the end of each 20 years. So we have the value of R, the amount needed to partially rebuild the bridge is equal to, we have that is equal to 100 million. As you can see, in this problem, we don't have an annual maintenance of the bridge. So therefore, we may assume that A is equal to 0. So let us compute for the capitalized cost. Capitalized cost is equal to our first cost, that is equal to 250 million. Okay? Then plus, every 20 years, that is the value of our small r, that is equal to 20. Every 20 years, you are to spend 100 million. 100 million that is divided by 1 plus. The given rate is 6%. We are to spend 100 million every 20 years. That is 1 plus 0.0, 6 every 20 years. So 20 minus 1. So this will be the capitalized cost of the bridge. We have 2,295,000. So 295 million $307,595. 307,595. So our closest value for the answer, we have letter C, 295.3 million. So that's our example for capitalized costs. We proceed to depreciation. So if we say depreciation, that is the loss of value of a property due to its use or due to its age. So for example, you can buy a cell phone at present. Let's say the price of the cell phone is 30,000 pesos. If you are to sell it 5 years later, you cannot sell it at the same price of 30,000. So that is, for example, you are to sell it at 15 or 10,000. It depreciates to a smaller value. So we have several procedures for depreciation, for the computation of depreciation. We have the simplest method, that is the straight line method. So for example, for this diagram, let's say at 0 year, okay, that is our first cost, corresponds to first cost. So as time goes by, the value of of that property will go down. After its useful life, you can sell it with this scrap value or the salvage value. So after n years. So this will be the value, let's say this of n, that is the total depreciation after n years. So using this diagram, we can determine the value somewhere between 0 and n. So let's say we have this of r and the book value r. So for example, how to compute for book value r? So we can have it by as ratio and proportion of similar triangles. So this period is the same as n that corresponds dn, while this period is r that corresponds to value of this of r. So by ratio and proportion of similar triangles, that is, we have this of r is to r is equal to this of n is to n. So this is this of n is to n. So how to compute for this of r? Obviously, you can have this of r equal to this of n multiplied by the ratio of r is to n. How to compute for this of n? Comparison sa 5. So we have basically, first cos is equal to this of n plus the salvage value. How to compute for this of n? That is the same as the first cos minus the salvage value. How to determine this height? That is the first cos minus salvage value. So how to compute for book value r? If we have the value of this of r, first cos will be always equal to this of r plus this of book value. This is the book value r. So if we are computing for book value at r here, that is the same as the first cos minus this of r. Okay, so let's have an example. So for our example, so a lot costing 3 million pesos has a salvage value of 0.1 million, or that is the same as 100,000. It can be used for 5,000 hours, so this is our n, in its entire life. Find the book value using, after using it for 1,000 hours. So usually if the method is not given, so usually you can use straight line method or the other method later, that is the double declining balance, or the declining balance method. So let us just use straight line method. So we are looking for the book value at 1,000 hours. So we have this of n is equal to the first cos minus salvage value. So how to compute for this height? This height less this one. So we have the accumulated depreciation is equal to 3 million, or that is minus 100,000. So we'll be having a total depreciation of, this is the same as 2.9 million, or 2,900,000. So by ratio and proportion of similar triangles, we have the this of r is to r is equal to the this of n is to n. So this of r is to 1,000 hours is equal to this of n is equal to 2.9 million, or 2,900,000 is to 5,000 hours. So what will be the accumulated depreciation after using 1,000 hours? So you have 580,000. That will be the accumulated depreciation after using it for 1,000 hours. Since we are looking for its book value, the book value r is equal to first cos minus the this of r. So we have the book value after using it for 1,000 hours is now equal to, our first cos is 3 million. Less 580,000. So we'll be having a value of 2,420,000. So that will be the book value after using it for 1,000 hours. So in our choices we have, that is letter C. So we may use, again, if you are using this calculator, having the same which is allowed by PRC, having the same functions as the 570 plus, you can use mode stat for this example. So this will be our solution number 2 using mode stat of the calculator. So let's say you may press mode. So this is the same as mode number 3. Then choose number 2, which is corresponds to linear. Okay, linear. Let's say press 2. We'll be having the 2 columns. This is the columns for X and Y. X represents the number of years or the period. Y represents the book value. So we press 0. That corresponds for 0. We have the first cost that is equal to 3 million. Then we have its useful life, N, is equal to 5,000, and the corresponding value at that time will be the salvage value, which is, our salvage value is equal to 100,000. Okay, so we may enter the data. 0 corresponds to the first cost, then N corresponds to the salvage value. So after entering the data, we may press CA. So press CA, that is for clear all. Then we are looking for the book value at 1,000. So enter 1,000. So we are to enter 1,000. Then shift ups. We do shift ups. Then look for regression. This is number 8. So you may press number 8. Then number 5. That is the Y hat. So press number 5. So what is on screen of your calculator? On the screen of your calculator should be the 1,000 Y hat. That is the same as our book value. Okay, the book value of the equipment after using 1,000 hours. Or after using it for 1,000 hours. Then press equals. That will be equal to, we have 2,420,000. So the same as our answer using formula. And this is our solution for solution 2 using the mode stat of Canon F-789 SGA, which is again allowed by PRC4 Civil Engineering Board Exam. We will proceed to the second method of computing or analyzing depreciation. So we have the sinking fund method. Still, this is a uniform method since you have a uniform value of depreciation every, let's say every period. So let's say this is the uniform depreciation. So this uniform every period. So if we are to recall what is our equation for the annuity, that is the future amount is called the annuity. This is multiplied by 1 plus I raised to n minus 1. This is divided by I. It has the same concept as the concept of the future amount of annuity. So here in sinking fund method, instead of using F, we are using D sub n. That is the future amount of the depreciation. Instead of using A, we are using D, that is the uniform depreciation value, then multiplied by 1 plus I raised to n minus 1, this is divided by I. So, sinking fund method basically from the equation of annuity. So, which means you cannot solve, you cannot use sinking fund if I is not given. So, I should be so that the rate of interest should be always be given so that you can use sinking fund method. So how about how to compute for D sub R? So we have d sub r is equal to the uniform depreciation value is multiplied by 1 plus I. If this is d sub n for n years, you have to use n as exponent. So for r years, you have to use the exponent r minus 1 divided by I. So the same, how to compute for the book value after r years. So we have book value r is the same as the first cost minus d sub r. So this is sinking fund method. So let's have an example. Okay, so let's have our example for the sinking fund method. So a dump truck was bought for 300,000 pesos 6 years ago. It will have a salvage value of 30,000 pesos 4 years from now. So therefore, what is our present R? Or on what R year? That is on the 6th year. So since the dump truck was bought 6 years ago, we are on the 6th year. So it will have a salvage value of 30,000 pesos 4 years from now. So that is 6 plus 4, we have its useful life of 10. Okay, so present at 6. 4 years later, it will have a salvage value of 30,000. That is on the 10th year. So what is the book value now if sinking fund method of depreciation is used at 6% interest per year? So again, you cannot use sinking fund method if the rate of interest is not given. So one clue, if the method is not stated, so you may use sinking fund method if the rate of interest is given. So we have, first, we need to determine d sub n. So again, d sub n is the first cost minus the salvage value. We have the accumulated depreciation is equal to 300,000 less 30,000. So we have the accumulated depreciation of 270,000. So we need to determine the uniform depreciation value. So can you recall, all you have to do if you are using sinking fund method, you have to recall the formula for future amount of annuity. That is d sub n equal to d. This is multiplied by 1 plus I raised to n minus 1 divided by I. So we have, that is d sub n, 270,000. That is equal to the uniform depreciation value multiplied by 1 plus 0.06. That is good for 10 years. Minus 1, this is divided by 0.06. So what will be the value of the uniform depreciation? Is equal to 20,484.3, let's say 349. I'm using 3 decimal places. So 20,484.349. Okay, let us determine the value of d sub r. Okay, we have d sub r is equal to the uniform value of depreciation multiplied by 1 plus I. All you have to do is change the exponent to r minus 1 divided by I. So we have the depreciation. This is the depreciation on the 6th year. Let's say d sub 6 equal to 20,484.349. This is multiplied by 1 plus 0.06, good for 6 years, minus 1 divided by 0.06. So this is the accumulated depreciation of the truck after 6 years. So we have a value of, we have d sub 6 na equal to 142,884 point, let's say 85 That is the accumulated depreciation after 6 years. We are looking for the book value. Book value number 6 is equal to first cost minus depreciation for 6 years. So how to determine this height? Okay, the first cost minus the depreciation. So we have this is equal to, our first cost is equal to 300,000 minus 142,884.859. We have the value is equal to 157,115.14. So let's check our choices. We have the value letter B, that is equal to 157,115.1. Alright, that's our solution for this example. So our next method of depreciation, we have the sum of the years digit method. So we have, from this diagram, how to compute for the d sub r, that is equal to the summation of d1 plus d sub 2 plus up to the d sub r. Take note that this is a non-uniform method. Non-uniform method, which means the depreciation on the first year is not the same as the depreciation on the second year, and not equal to the depreciation on the third year, and so on. So non-uniform method. You can compute for the depreciation per year since they are not equal. So how to compute for the depreciation on a specific year? Let's say d sub r is equal to k sub r, that is the rate of depreciation multiplied by the d sub n. As the equivalent of the rate of depreciation k sub r, we have that is on the r year minus 1 plus, or that is n, the number of useful life minus r plus 1. This is divided by, why is it called as the sum of the years digit method? You are to add up the sum of, you are to add the digits of the years. That is 1 plus 2 plus 3 up to plus n. As you can see, the denominator is in arithmetic progression, that is the same as n minus r plus 1 divided by the last term, or the number of terms over 2, that is the last term plus the first term, which is 1. This is the equation of k sub r. So again, this is another non-uniform method. D1 is not the same as D2 as D3. So to determine the accumulated depreciation at r year, you have to sum up. You need to compute for the depreciation per year. So let us have an example. Okay, so let's have an example for the sum of the years digits method. So what is the book value of equipment purchased 3 years ago at 15,000 pesos? So the expected lifespan is 15 years. Use sum of the years digit method. So we have the value of r is equal to 3 and the value of n should be equal to 15. Okay, for this case, as you can see, we don't have a salvage value given in this problem, and we don't have a way to compute for the salvage value for this problem. So if that is the case, all you have to do is assume that the salvage value will be equal to 0. That makes d sub n. So again, we have first cost is equal to the d sub n plus the salvage value. But if the salvage value is 0, that makes the first cost simply equal to the total depreciation at n. So we are looking for the book value. We are looking for the book value after 3 years. So we need to determine the depreciation per year again. So since this is sum of the years digit method, D1 is not the same as D sub 2, not the same as D sub 3. We need to compute them individually. So we have, that is, at R is equal to 1, we have K sub 1 that is from our equation for the rate of depreciation. This is the case of r is equal to n minus r plus 1 divided by n over 2 divided by n plus 1. So we have r is equal to 1. Let's say this is case of 1 is equal to useful life. We have 15. This is 15 minus 1 plus 1 divided by 15 over 2 divided by 15 plus 1. So what is our case of 1? So the case of 1 is basically equal to 1 over 8. So if you are computing for the depreciation on the first year, that is equal to case of 1 multiplied by d sub n. So we have the depreciation on the first year is equal to 1 over 8. What is the value of d sub n if salvage value is equal to 0? The same as the first cost, which is 15,000. So you have the depreciation on the first year is equal to 1,000. This is 1,875. So take note, this is the depreciation on the first year only. So let's compute the depreciation on the other years. So we have the next one. This is at r is equal to 2. On the second year, we have r is equal to 2. That is equal to case of 2 is equal to 15 minus 2 plus 1 divided by 15 over 2 divided by 15 plus 1. So you may compute the value of the denominator so that you are not to recompute it all over again or repeatedly. So this is 15 minus 2 plus 1 over 15 over 2 times 16. That is equal to, and we have 7 over, this is 7 over 60. So we have case of 2. This is case of 2 is now equal to depreciation on the second year. This is d sub 2 is equal to the case of 2 multiplied by the d sub n. Depreciation on the second year is equal to 7 over 60. This is multiplied by 15,000. So we have that value as 1,000. As you can see, this is not equal to d sub 1. We have 1,750. It is not equal to this one, and it is decreasing. Okay? Then we have on the third year, since we are looking for the book value on the third year, and we have at r is equal to 3. We have, let's say, case of 3 is equal to 15 minus 3. This is plus 1. Divided by 15 over 2, divided by 15 plus 1. So we have the case of 3 is equal to this is equal to 13 over, let's check. This is equal to 13 over 100. 13 over 120. So we have the depreciation on the third year equal to k sub 3. This is d sub n. Depreciation on the third year is equal to 13 over 120 of 15,000. So depreciation on the third year, so it is expected to be less than 1,750. That's equal to 1,000. This is 1,625. Alright. So the accumulated depreciation on the third year, d sub r, and that is the d sub r is equal to d1 plus d2 up to the d sub r. So let's say this is the accumulated depreciation on the third year, that is d1 1,875 plus d sub 2 1,750 plus d sub 3 1,625. Accumulated depreciation on the third year is equal to 5,000. This is the same as 5,250. So to compute for the book value on the third year, equal to first cost minus d sub 3. What is our first cost? We have 15,000 minus 5,250. So we have the book value after 3 years is now equal to 9,750. So that will be our answer. So this is the conventional procedure of computing the book value for book value using the sum of the years digit method. And let's try second solution again using the mode stat of Canon F-789S GA. So solution 2, we may use mode stat. Let's say that is mode stat, mode number 3. So let's say mode stat number 3. We are to use this time number 3. That is quad. I think it represents quadratic. Alright. So press 3. Again, we have the columns for the x and y. Again, y represents the book values and x represents the number of compounding period or years. Okay, our sets will be 0. We are to place the first cost here, which is equal to 15,000. Then useful life, we have 15. You are to place the salvage value, which is for this case, our salvage value is equal to 0. Then you will be having a third row. The third row will be the same will be equal to n plus 1. That is 15 years useful life plus 1, 16. Then you are to repeat the salvage value, which is the same as 0. So let us input the data. We have 0, 15, 16. Salvage value, first cost 15,000. Salvage value is 0. 0. After entering the data, you may press CA for clear all. Okay, then we are looking for book value number 3. Since we are looking for book value number 3, you press 3, then shift ups. So press 3, shift ups, then look for regression. That will be number 8. So press 8. Okay, we are looking for y hat. This time y hat is at number 6. So press number 6. What is appearing on the screen should be the same as 3 y hat. This is the same as the book value after 3 years. Then press equals. That is equal to, we have 9,750. We will be having the same answer as a conventional procedure. And that's our one shortcut for the salvage value, for the book value, computation of book value using sum of the years digit method. So we proceed to the next procedure for the computation of book values or depreciation. Okay, we have the declining balance method. For example, we have a first cost of 1,000. Let's say your constant discount is 20%. What will be your new selling price? Your new selling price is the same as your book value. So it's the same as 1,000 minus 0.20 of 1,000. That will be equal to minus 200. You have 800. Then if it is, or this process will be repeated, we have 800. So this constant percentage of the declining value, that is the same as 20%. This will not change. It's the same as 800 minus 20%. We have 20% of 800. So 0.20 of 800, this is the same as 600. Okay, 640. So let's say this is your book value number 1 and this is book value number 2. How did you compute for those value? So how to compute for book value number 1? Book value number 1 is the same as your first cost ay minus the rate of depreciation K multiplied by your first cost. So you have your book value number 1 as first cost multiplied by 1 minus your rate of depreciation. How did you compute for book value number 2? Take note, this 800 is book value 1. This is the rate, this is book value number 1. How did you compute for book value number 2? Book value number 2 is equal to book value number 1 minus the rate of depreciation times book value number 1. Okay, book value number 1. So, we have the equivalent of book value number 2. We factor out book value number 1. This is book value 1 multiplied by 1 minus the rate of depreciation. What is the equivalent of book value 1? So, we have okay, book value number 2. Equivalent of book value number 1 is first cost multiplied by 1 minus the rate of depreciation. That is the equivalent of book value number 1 multiplied by 1 minus K. So we'll be having the equivalent of the second book value as the first cost multiplied by 1 minus the rate of depreciation squared. So from that equation, we may generalize the formula. This is the same as book value R, book value number 2 is equal to the first cost multiplied by 1 minus the rate of depreciation. If this is sub 2, what is the superscript? The same as R. The superscript is the same as, or the exponent is the same as R. So this is the general formula for the computation of book value using the declining balance method. So on the last process, your last book value will be the salvage value. So let's say this is the salvage value, that is, the salvage value is equal to the first cost multiplied by 1 minus K. If it is the salvage value, that is on the useful life end. So this should be raised to n. So how do we compute for the rate of depreciation? So the rate of depreciation will be salvage value 1 minus. It is the same as the salvage value over the first cost. This is raised to 1 over n is equal to 1 minus K. So the equivalent of the rate of depreciation will be 1 minus the quantity salvage value over the first cost raised to 1 over its useful life. So that is the equivalent of rate of depreciation. So these are the key equations, book value and the rate of depreciation. So what is the limitation of declining balance method? Kumbaga, kailan siya pwedeng gamitin, kailan hindi? What is the limitation of declining balance method? So, the salvage value should not be equal to 0. That is the one rule for declining balance method. The salvage value cannot be equal to 0. Okay? So let's have an example. Okay, problem number 15. So determine the accumulated depreciation at the end of 8 years for an asset that costs 15,000 pesos and an estimated scrap value of 2,000. Okay, at the end of 10 years. So we are looking for the list of 8. Accumulated depreciation after 8 years. So we may first compute for the rate of depreciation. That is 1 minus salvage value divided by the first cost. This is raised to 1 over its useful life. The rate of depreciation, 1 minus our salvage value is 2,000 divided by the first cost, 15,000. This is raised to 1 over 10. So let's compute for the rate of depreciation. is equal to 18.249%. So let us compute book value R is equal to the first cost divided by 1 minus k raised to R. So let's say we are computing for book value number 8. Our first cost is 15,000 divided by 1 minus the computed rate of depreciation 0.18249. This is raised to 8. So we'll be having the book value after 8 years. Is equal to 2,992.512. That's our book value for book value. But we have here on the choices letter A, but that is not the required. We are looking, take note that we are looking for determine the accumulated depreciation after 8 years. We are looking for this of 8. So how to compute for this of 8? Okay, how to compute for this height? So again, we have first cost is equal to the Ds of R plus book value R. Therefore, if you are computing for Ds of R, this is the same as first cost minus the book value R. So we are computing for Ds of 8. Our first cost is 15,000 minus book value after 8 years is 2,992.512. Accumulated depreciation after 8 years is equal to 12,000. This is 12,007.49. That will be our answer. So let's check on our choices. 12,007.4. We have letter. In this problem, we have letter C. So that is our first solution. So again, we may use another solution. Let's say this is solution number 2. And we have, again, we're using mode stat or mode number 3. So we have mode 3 is mode stat, or I'll be using number 6. So I'll be using number 6. This is applicable only for the declining balance method. Let's say this is AB, and then EXP. So plus number 6, again we have the two columns. For X, number of years, Y for the book value. So we have at 0 year, that is corresponding value is first cost, we have 15,000. At useful life, we have 10. We have the salvage value, which is equal to 2,000. Okay, so we input the data. We have 0, 10. First cost is 15,000. Then salvage value is 2,000. Okay, so again, we may press clear all. Then we are looking for, we can compute for book value. So if we can compute for the book value, and that is book value number 8. That is, we may enter 8. Then shift ups. So shift ups. Then look for regression. Again, regression is number 8. Then look for y hat. So y hat is number 5 this time. So supposedly, what is appearing on your screen, on the screen of your calculator, is the 8. This is 8 y hat. That is the same as the book value number 8. So we have press number 5, then press equals. That's equal to 2,992.56. Again, this is not the required. We are not looking for the book value number 8. We're looking for depreciation number 8. So if we are to if we are able to compute for book value number 8, then first cost less than book value number 8 will be the depreciation on the 8th year. So this is our answer. All you have to do is, after determining the book value, follow this process. That is applicable for the declining balance method. So our next method of depreciation, we have the double declining balance method. So we'll be having the same equation for the computation of book value as the declining balance method is equal to first cost 1 minus the rate of depreciation raised to R. It's just we have another way in computing its rate of depreciation. Simply for double 2 over n, the useful life. So this is the way how to compute its rate of depreciation. So let's have an example. So the cost of a machine is 140,000 and has a useful life of 8 years and a salvage value of 10,000. It doesn't matter if we have a zero salvage value or if the salvage value is given, since you will not be needing the salvage value for the double declining balance method. Okay, so find the depreciation charge during the 4th year, use double declining balance method. So we are looking for the depreciation charge on the 4th year, that is D sub 4, which means on the 4th year only. It is not the D sub 4, the accumulated one, but it's on the 4th year only. If we are to analyze our diagram, let's say this is the book value on the 3rd year, and this will be, of course, you will be having a decreasing book value on the 4th year. The difference of the two will be the depreciation on the 4th year. So what is lost from its value on the 3rd year going to the 4th year? So basically we have D sub 4 should be equal to the book value on the 3rd year minus the book value on the 4th year. Alright, the depreciation charge on a specific year or on 1 year. So we have D sub 4 is now equal to book value number 3. That is the same as, what is our first cost? 140,000. This is multiplied by 1 minus, what is the rate of depreciation? 2 over n. We have 2. What is its useful life? Useful life of 8. Book value number 3, we have raised to 3. Minus, book value number 4, 140,000. This is multiplied by 1 minus 2 over 8. This is raised to 4, since that is book value number 4. This is the depreciation charge on the 4th year only. So you have the value of 14,765.625. So this is this is for 4th year only. This 14,765.6. We have on our answer choices. We have letter D. So you can use a method here for calculator, but that is very inconvenient since it is the same as you are inputting this equation. So I'm not recommending that procedure. So our next example will be under the break-even analysis. So a manufacturer produces a certain items at a labor cost of 100 pesos per item, material 76 pesos each, a variable cost of 2.32 per item. If the item has a unit price, which means you can sell per item at 600 pesos, or that is the selling price, how many numbers of units must be manufactured each month for the manufacturer to break even if monthly overhead, that is the same as the overhead cost equal to 428,000. So let's say X will be represents the number of items for break even. So for break even analysis, break-even analysis, we don't have a specific equation or a specific formula. All we have to do is, basically, for break-even analysis, you have to equate your income. You have to equate your income to your costs or your expenses. Break-even analysis, your income should be equal to your expenses or the costs. So, how do we have an income? So, paano tayo magkakaroon ng income? How to have the value of the income? That is basically the number of items that is to be sold at 600 pesos. That will be the total income. Okay, so you have to sell X number of items, 600 pesos each. Should be equal to what are your expenses? You have your overhead cost is equal to 428,000. Plus, what are the expenses in producing X number of items? We have, let's say, that is X multiplied by how much is the labor cost? 115 plus material 76 plus 2.32, the variable cost. So this is the total expenses in producing X number of items. Let's compute for the number of items for break even. So we have, this is 1052.42, and it should be round up. This is equal to 1,053 items. Why is it round up? For reason, you don't have 0.42, for example, 0.42 cell phone, 0.42 cars. There's no such thing as 0.42 when it comes to exact number of items. So always do round up. So we have the number of items is 1,053. So this is a past board exam. So majority of our examples are board exams in the past. Our next topic will be the rate of returns, or the ROR. Now, to compute for the rate of return, that is basically the ratio of your net income divided by your first cost or your capital divided by 100%. This is the main idea for ROR. So let's have an example. So an investor pays 1,100,000 for a mine which will yield an income of 200,000 pesos at the end of each year for 5 or 10 years, and then will be useless. So based on the problem, you have a capital of 1,100,000 that will be your first cost. Then after 10 years, so on that mine will be useless. So we may assume that the salvage value will be equal to 0. Since our little problem, it will be useless. So he accumulates a replacement fund to recover his capital by annual investments at 4.5%. That will be the rate of interest. So at what rate does he receive the interest on his investment at the end of each year? So all we have to do is determine the net income. We have this income, but maybe this is the gross income. So we need to remove, or we have to deduct the depreciation charge, or that is the same as the hidden depreciation charge or hidden charges. That is, we need to remove this one, the annual depreciation. This is a hidden cost. That is the annual depreciation cost. So how to determine that value? We may use here. So the common procedure to use for depreciation for this case, if we have I, is the sinking fund method. Alright, so we're using sinking fund method. So we have the first cost is equal to the days of N plus the salvage value. But again, for this case, according to the problem, the salvage value will be equal to 0. This means our first cost is the same as our days of N equal to the 1,100,000. So from the sinking fund method, what is the equivalent of days of N equal to the annual depreciation cost? This is multiplied by 1 plus I raised to N minus 1 divided by I. So we have days of N, this is 1,000,000. This is 1,100,000 equal to the annual depreciation cost multiplied by 1 plus the given rate, that is equal to 0.045. This is good for 10 years. Minus 1 divided by 0.045. So let's compute for that value. So we have the annual depreciation cost of 89,516.70. So let us determine the net income. So net income, we have the gross income, which is given as 200,000. This is less 89,516.70. Actually, if we say depreciation cost, that is an indirect cost. Okay? So we have the net income will be equal to is equal to 110,000. 110,483.296. This will be the net income. Your gross income less your annual depreciation cost. So we have the rate of return is now equal to your net income 110,483.296. This is divided by your capital or your first cost. We have 1,100,000. So multiplied by 100 to be in percent. So we have the rate of return is now equal to it will be equal to 10.04%. This will be your rate of return. So all you have to do if you are computing for the rate of return, determine the net income. So that is your gross income less or your expenses or your cost. If it is not stated in the problem, take note that we have a depreciation cost. It is a hidden or indirect cost. You need to deduct that. Now if we have now that net income divided by your capital, that will be your rate of return. So let's check the choices. We have this is letter D, 10.04.